my team.
Hi, my name is Hadida Batisha binti Muhammad Zabulisha.
Hi, I'm Nur Amanda Syahira bin Umar Sabri.
Hi, my name is Nuri Madia binti Ahmad Hamad.
Today, we will present about the
Hospital.
Operation
Audi.
Let's go!
For the introduction, hypothesis testing is used to make conclusion or decision about a population based on the data taken for a sample. In the following case, the decisions are made about the population mean.
Two-sample hypothesis test is a statistical method used to compare the means of two independent groups to determine whether there is a significant difference between them. The key idea is we are testing whether the difference between two sample means reflects a real difference in populations or it just due random variation. For examples, comparing travel time, route A versus route B. Example 2 is comparing the effectiveness of drug A versus drug B.
A statistical test used when the data are dependent or paired, meaning the same subject are measured twice. Key idea, instead of comparing two separate groups, we analyze the difference within the same group. For example, before versus after treatment, energy levels of nurse before and after a yoga program.
Okay, for this slide, I will explain the main difference between two sample tests and parity tests. For two sample tests, we compare two different groups. For example, students from two different classes. These groups are independent, meaning they are not related. But for parity tests, we use the same group. For example, before and after treatment. So the data is related because it comes from the same person. So in short, two sample tests compare two different groups, while parity tests look at the difference within the same group. Now, for this example, we don't solve the calculation yet. First, we need to identify which test to use. There are two important things to check. First, the sample size. Here, the sample is 35, which is more than 30. Second, the population standard is given, which is 1.2. So, when the sample size is large and population standard deviation is known, we use z-test. Also, the question asks whether the mean is equal to 16, so this is a two-tailed test. For this example, we do the same thing. Identify the test first. The sample size is 10, which is less than 30. Also, population standard deviation is not given, only sample standard deviation is given. So, in this case, we use t-test. The question says at least 2 years, so it shows direction to us. This means it is a one-tailed test. So overall, to choose between z-test and t-test, we look at the sample size, whether the population standard deviation is known. So that's how we identify the correct test. Next, I will pass to my friends who will continue with the next part.
Hello everyone, in this video, we will discuss about our questions. Let's get started!
Step 1. Defining our hypothesis. Our null hypothesis assumes that both groups are the same, while our alternative hypothesis claims that they are different. Since we are looking for any difference, we use a two-tailed test. To calculate the test statistic, we calculate our test value using the z-test formula for two independent means. Based on our data, with sample means of 3.5 and 3.3 and their respective variance and sample size, the calculation is as follows. This gives us a calculated z value of 4.039. In the third step, we set our significant level at significant equal 0.05 because it is a two-tailed test. We divide alpha by 2, giving us 0.025 for each tail. Looking at the standard normal distribution table, the critical Z values are positive and negative 1.96. As you can see in the diagram, any test value falling beyond this point enters the rejection region. Step 4. Make a decision. Now, we compare our result. Our calculated test value of Z equals 4.039 is much higher than the critical value of 1.96. This means it falls deep within the critical region. Therefore, we have sufficient evidence to reject the null hypothesis at the 0.05 significant level. Step 5. Finally, we conclude that we accept the alternative hypothesis. This indicates that there is a statistically significant difference between the two means null A and null B.
So, let's move on next question 2 with Mardia.
Next, the medical board asks you to evaluate the effectiveness of two blood pressure medications to see if the drug B, 45 patients, mean 18 mmHg, standard deviation, population 4 mmHg show a higher reduction than drug A, 15 patients, mean 15 mmHg, standard deviation, population 3 mmHg at a 0.01 significant level. So, for the answer is, to evaluate the effectiveness of two medications, we first establish our hypothesis. The null hypothesis, pronounced as H null, states that the mean reduction of drug B is less than or equal to drug A. Mu B is less than or equal to mu A. The alternative hypothesis, or H1, claims that drug B show a higher reduction, meaning mu B is greater than mu A. For the step 2, we use a two-sample Z test because the population standard deviation are known. The formula for the Z-score is the difference between the sample mean divided by the standard error. Mathematically, we calculate this as 80 minus 15 divided by the square root of 4 square over 45 plus 3 square over 50. This calculation results in a test value of Z equal 4.10. For the step 3, we are testing at a significant level of alpha equal 0.01. Looking at the standard normal distribution table for a right tail test, our critical value is Z equal positive 2.33. As shown in the bell curve graph, any value to right of 2.33 fall into the shade rejection region. For the step 4, now we compare our result. Since our calculated test value of 4.10 is much higher than the critical value of 2.33, it falls deep into the critical region. Therefore, our decision is to reject the null hypothesis at the 0.01 significant level. In conclusion, there is strong statistical evidence to support that drug B is more effective than drug A, or simply put, the mu B is greater than mu A.
Let's move on to Amalina for question 3.
This is question 3. While there, the psychiatric department wants to verify if a new VR therapy with 25 patients, mean score of 40 and standard deviation of 5 is more effective for treating anxiety than traditional medication, which has 15 patients, mean score of 42 and standard deviation of 6 at a 0.01 significant level. Now that we know the problem, let's solve this question together. So, for VR therapy, the sample is 25, mean 40 and standard deviation 5. Then, traditional medication has 15 samples, mean 42 and standard deviation 6. That's all for 8. Then, the significance level is 0.01. Then, moving on to step 1. Since this is a 2-sample t-test, we need to do it like this. For hash now, it is mean 1 more than mean 2. Then, mean 1 is lesser than mean 2 for hash alternative. This make it a one-tailed test and left-tailed. Then, moving to step 2, this is the formula. The formula is T equals to mean 1 minus mean 2 over SP times the square root of 1 over N1 plus 1 over N2. N stands for samples. Then for SP needs to be found to be used in the T formula. So this is the formula for SP. SP is equals to the square root of N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared over N1 plus N2 minus 2. Then we will kick in the number into the formula and get 5.39 for SP. Then we will kick in the SP and the other numbers in the formula and we will get the answer. The answer is negative 1.136. Then we will move on to step 3. The significance level is 0.01 and the degree of freedom is 38. Then we will get the value of 0.0138 and the t value for it is 2.429. Then we will kick in the graph, we draw the graph and put the value. Then we get the t value from before and put it in the graph. Then for step 4, we will say the test value t equals to minus 1.136 falls in non-critical region. We need to highlight the non-critical region. Then we will say that accept hash null at 0.01 significance level. That is the answer. In step 5, we will write back the hash null and we will write this sentence, which is the VR therapy is more effective than traditional medication.
So for the next question, let's move on to Alina.
Hi everyone, this is Alina and today we are going to solve question number 4 together. To show our hospital commitment to staff wellness, we analyze a 4-week yoga program for 10 nurses. We record their energy level on a scale of 1 to 100 to see if there was a significant increase. Let's look at the data. By comparing the before and after score for each nurse, we found the differences. Every nurse showed an improvement, with their score increasing between 2 to 5 points. First, the mean of differences, or X bar, is 3.7. Then the standard deviation or sigma is 1.160. These numbers are essential for our t-test later. In step 1, we set our hypothesis. Our null hypothesis or H null is mu equal to 0, meaning that no improvement energy at all. Second is our alternative hypothesis H1 is mu is greater than 0, meaning energy level increase. So this is a one-tailed right-tailed test. In step 2 and step 3 calculation, after plugging in the number, our calculated t-value is 10.09. At a significant level of 0.01 and 9 degrees of freedom, our critical value is 2.821. As you can see on the graph, our value falls right into the shaded critical region. To wrap it up, in step 4 and step 5, since our test value is much higher than the critical value, we reject the null hypothesis. This proves that the yoga program successfully improved the staff energy level. That's all for question number 4. Thank you.
Conclusion, hypothesis testing is a statistical method used to decide whether to accept or reject a hypothesis based on sample data. If the p-value is less than the significant level, the null hypothesis is rejected. Otherwise, it is not rejected. Overall, it helps researchers to make objective and data-based decisions.